So welcome everyone. Welcome to the third lecture of how to draw a plot or rather play with graphs, right? So in the last class, what we have learned, we have learned the equation of straight line, and in the last lecture, we have taken various example from chemistry, and where you need to draw a plot which will be straight line. It's like how to be familiar with the plots that will be and that are there in the chemistry. So that we have already discussed. Some of those are like Charles law, Boyle's law, and gasoline is how compressibility factor with pressure, all the things. So we have completed straight line. Right? In this now today's lecture, we will try to solve some polynomial equation with that kind of problem. Obviously, very simple one. We will start with. So to start with, what is a polynomial? That means it is a degree of the dependent variable. How much whatever the straight line is, it's to the one, right? It's one of the first order polynomial. But how the plot will look if it is x square or it is a cube or it is x to the power half, right? So these things will learn in the today's lecture. Okay? So in the first class I have to some approach, right? Some approach I have to one of the approach was if you know the value of x and if you know the value of corresponding y, right? Then if this is 1, this is something. If this is 2, this is something. This is 3, this is something. Like that. So you can, without wasting your brain, you can simply draw that. That is always there for any kind of function. You can find that you can draw the curve. But we are not talking about that. We want to avoid that, and smartly we want to just by looking at the equation we want to draw it. Okay, so that approach is like always like compare it with your known function. Let's say this is my known function. Okay, so it is given that plot y is equals x square. So always compare with y is equals x. So with respect to y is equals, if you know what is y is equals x, then how you will get to know what will be y is equals x square. Before going to that, I'll obviously talk about this. But before going into that, let me give you some small points, right? Any function, any arbitrary function can be written as a linear combination of odd and even function, right? Odd and even function. So you need to know what is odd function, what is even function. If your f(x), f minus x is equal to f(x), now if your f minus x is x, then it is f minus x. If minus x is actually giving me fx, then it is even function. If it is minus fx, then it is an odd function. Let me give you an example. Let's say your function is y is equals x square, right? So if you take x is equals minus 2, so what will be your y? Well, plus 4, right? So and if you take y is equals 2, then also it is y is equals 2. So that means if you put minus x in place of x, you will be again getting x square. So this function is nothing but even function. Right? This is just an example. Whenever wherever it is x, just replace it with minus x, and then see what is the sign you are getting. In this case, this is let's say sin x. Y is equal sin x. So if you put replace 2x with minus x. That is the process to check whether the function is odd or even, right? So just replace it. Sin minus x. You know sin minus x is always minus. So this function is nothing but an odd function, right? This function and any function. Let's say this is fx. Any function can be written as a linear combination uh, of odd and in any uh, function can be written as linear combination of fx is equals hx plus gx, right? So this is your odd function, this is your even function, right? So let's take hx is odd function. So if x plus if sorry so this is your hx, this is your gx. Why I'm writing this? Because this is odd, this one is even, right? Why I have written it like this? Because these are odd, this is even. So just check it. Hx, you just put minus x here. So replace all x with minus x, right? So minus f of minus x, right? By 2. So that means f of minus x minus f of minus will be plus fx by 2. So if you take a here, then it will be fx minus f of minus x. So this is nothing but minus of hx, right? Whatever we have started with. And let's check the gx. Let's check the gx. This is sorry g minus x. We have fx that needs to be f minus x plus f of minus x, right? By 2. So what it will be f of minus x plus f of x by 2. So this is nothing but the first one. So this one is even, this one is odd. Let's now just add up fx is equal to what we are looking at. Gx plus hx. So this is nothing but fx minus fx plus f of minus x by 2 plus f of x minus by 2. So this is so if gx that is an even one, hx is an odd one, any function fx can be written like that. Okay. So this is a property of a function, right? Now the best part about knowing a function odd or even, if it is like if the function is odd or even, then you can write down the like you can draw the flaw in a way like any, let's write it down in the color, okay. Any function and function that is on. In case of even, it will be symmetric above x equals 0, that means y-axis. Right? In this case, if it is odd, it will be symmetric above y is equal to 0, that means x-axis. Right? So this is that. If it is even, so now we know y is equal to x square. What function it is? This is even function. Because for any value of minus x, we get y is equal to x square. Right? We get fx is equal to f of minus x. So this is an even function. So it will eventually be symmetric above this axis. So let's say this is not the plot. We'll discuss how the plot will be. But let's say if this is the plot, then it will appear like this. This is symmetric. This part from right, this will be symmetrical. And similarly, any kind of odd function will be symmetrical of x-axis. And odd function, one of the example I have given, that is sin x. If you recall the plot of sin x, you will find it out. So just check it by yourself that if the sin x function is symmetric or not over x-axis, right? Now come to the point. So what we have started asking, how to draw y is equal to x squared, right? So this was our ask. So what I told, compare it with one of the known function, that is y is equal to x. So if you compare that, it will become x is equal to x squared, x is equal to x squared. So that means you can write x minus 1, that is equal to 0. So that means we get x is equal to 0 or x is equal to 1. Then in these 2 points, when x is 0 and at x is 1, this y is equal to x square plot will touch y is equal to x line, right? So this is when y is equal to x. Last day we have discussed, because this is a straight line. This is 1 plus this is y is equal to x. Now, how we know at color? So we know at this point, that is 0, 0, that means sorry, x is equal to 0. Let's say this is 1, x is equal to 1. At these 2 points, this function will touch this. Now, what will happen in between and what will happen after that? Let's say if x is in between 0 to 1, right? If x is 0 to 1, that means x is nothing but a fraction, right? So at this region, we know x square will be less than x, right? Because any kind of fraction, it is greater than its greater than its square root. Right? Let me take an example. If x is equals half, that means x square will be 1 by 4. So which one is greater? This one, because this is 0.5, this is 0.25, right? So this one is greater. For any value, any fraction, the square value is lesser than x. In this region, obviously, this, because this function is y is equal to x squared, it will be lesser value than y is equal to x, right? And let's just check the other part. Whenever this x is greater than 1. That means this is whenever this x is greater than 1, obviously x square is always greater than x, right? X square is always greater than x. Why? Let's say x is 2, x square will be obviously 4. Whatever value you take to know. So x square is always greater than x. Now let me draw this. In this region, this is lesser value. In this region, this will be higher. Right? Because we are plotting going downwards, this y is equals x. Here it is going upwards. Now we know this one is even function. So you don't need to draw the other part analogy. You just directly draw this by simply knowing the logic that any even function will be symmetric about y-axis, right? This is my y-axis. Any function, right? Now, if it will give you, let's say y is equals x, how to draw it? Very similar. Just compare it to y is equals x, right? Now, what it will become? X cube is equals x. So it will become x square minus 1 is equals to 0. So 1 into x square is equals to 0. That we don't get x is equals to 0. And 1 into x is equals to 1, right? Same point. So here I will draw all the three plot in a similar graph. All the three plot, right? So now what is my x? Y is equals x. This is my y is equals x. Right? Y is equals x. Now just check it at this value 0 to 1. X cube will be obviously be lesser than x, right? Because if the square is lesser, cube is obviously much more lesser because just take the analogy 1/2, 1/4, and 1/8. This one is the higher, this one is this. So that means x cube is less than x square is lesser than x. So x will be the highest. So if you plot x cube 1, so this will be like this, right? And if you try to think how the x square will be in between 1. So in that region, how I will run that part. So whenever x is greater than 0, that time x cube will be much higher than x and obviously higher than x square. Just take the 2, 4, right? So this will be. So in this region, this 0 to 1 region, this will be like this, and the other region will be just exactly opposite. Now take the analogy of symmetric and non-symmetric. Now y is equals x square. You know it is symmetric. Sorry, given function, and y is equals x cube. Will not be given because minus x whole cube is equals minus x cube. So that means this is odd function, right? So x square is even function, or x cube is odd function. Now x square even means it will be symmetric about y-axis. It will be like this, right? But this one is odd function. That means symmetric about x-axis, right? So how it will look like? Okay, symmetric about x-axis, it will look like this, right? So this will be your one. So just simply by the logic, you can tell that this function is like you can tell how the function, the value of function, or how it will look like, right? Now, let me tell this y is equals to x square. This thing is called arbitrary parameter, right? Like y is equals to x is called the straight line. You already know similar to y is equals to x square is called parameter. So we just try to read a bit about parabola. This is not the only equation. Parabola can be of different types, about symmetric, about different types. So that's the normal picture of parabola is that this is the axis. Right? This one is was the x square. This one is the parabola. Okay. Now let's take one very exciting, one very interesting example. Y is equal to x to the power r. Now, the life looks a bit difficult, but it is not. It is not, because you can directly do it with the same amount. Because you know why? Because it's so very well. You always compare it with that, right? So how do you play? Now, if we compare, then if x is equal to x to the power half, right? You can write x to the power half into x to the power half x. You can write it like that, right? So if you on right, so x to the power half is 1, that is 2, and another is x to the power half is 1, that means x is increasing. So again, function, this function is cutting or intersecting that y is equal to x log at 2 points. One is x is equal to 0, another is x is equal to 0. So now we know everything. Just this one is nothing but y is equal to x, right? Now we know this one is 0 point. That's a position of 1 point. Right? This one is 1 point. Now, in between 0 to 1, in between 0 to 1, we know x square is greater than x. X cube is greater than x. Am I telling right? No. This is exactly different. This is this. In this range, this is the picture. This is the correct thing. And in this range, whenever it is x greater than 1, the trend is exactly different. Right? So we have got that plot change. Now if you think about what will happen for x half and x, what will be the relation? So the relation will be exactly different than this. Right? How? We just take one. Let's say your x is 1 by 4. Well, x to the power half, how much will be? So x to the power half will be greater than this. Right? And in this region, whenever it is 1, let's take x is equal to 4. So what will be your x to the power half? Will be 2. So whenever the x is higher than 1, that time x to the power half is less than x. And whenever it is greater than 1, that x to the power half is what? Greater than x. And at this time, this is less than x. So in this regime, it will go beyond this, but after this, it will be like this. This will be no y is equals to x to the power. Now, how y is equals to x square was? It was just exactly right. This one with y is equals x square. Right? So these two are mirror image of each other about the axis y is equals x. Right? Why this becomes this way? Just see this y is equals x square and y is equals x square. So if you just square it, x is equals to square. So it's nothing but interchanging. So it's nothing but interchanging of the axis. So just see it like that. So if this was your y-axis, this was your x-axis, if you just change it, if you just replace x with y and y with x, then the function will be like this will be your y is equals x to the power half and this will be your y is equals x square. So this is the thing. Okay. So you can draw such kind of plots by taking reflection with respect to y is equals x square. This is rule. This is one trick here, or you can say one rule number one. So y is equals x along reflection. Another one is to change the axis. Change y x axis. This is the case. So just this is your y is equals x. This is your y is equals x square. This is your y is equals right? Very easy. Now, let's say if you want to draw y is equals x to the power third and x given the same block. If this is the question you have been asked. So how you can draw it? This is very similar like this. So let's say y is equals x. You already know this, right? What is y is equals x? This is nothing but y is equals x cubed. Much more lesser in this system. Much more different. Right? This is and also this y is equals x cubed is symmetric about x-axis. So this this point is always x right? Now you need to draw y is equals x to the power half in the center. So we are told from 0 to 1 range, this function or x to the power 1 or x to the power any fraction will be higher than the number itself, right? So it will be like this. And in that region, it will be lesser. And similarly, in this region, like this. So this will be the just taking the reflection. You can also draw by using the analogy. You can also draw. So this is a very simple thing. So you can similarly try. I am not trying right now. Y is equals x to the power 4 and y is equals x to the power 1 by 4. Okay. Just remember x to the power 4 means again this is even. So symmetric about y axis. Right? So that's it. You can draw it similarly. Now If you want to know y is equals 1 by x and 1 by x squared. Here, like in this case, I am actually giving various mathematical functions, various kind of polynomial function, and trying to explain how we can draw. So let's just start with y is equals 1 by x. This one is a very interesting one. Again, just compare it to y is equals x. So what will be x is equals 1 by x? That means x is equals x is equal to plus minus 1. So this will uh, intersect your y is equals x at plus minus 1, right? Now, this one is the first one here, and this first one you got. Now just see, whenever this x is 0, so what will be y 1 by x? What will be 1 by x? It will be infinity, right? Whenever it is x is 0, and whenever this x is itself infinity, so something by infinity, that means obviously 0. That means y will be 0. So whenever this x is going to 0, y is becoming infinity. Whenever this x is infinity, y is becoming 0. Right? And third one, x, y. Because y is equals 1 by x, y is equals 1 by x. That means x, y is equals 1. So x, y is constant. Last also I told something like that. That is p pv is equals constant. So if you draw PV versus P, it will always be like this. There will be no change. But if you want to plot this, so let me go to that. So we have in hand 3 points. That x is plus minus 1 at this touching y is equals x. And at the point x is equals to that means that time the function will be value, and at point infinite of x, that is the function will be 0. Okay. So keeping these 3 things in mind, you can draw the function very easily. Okay. So this should be your original source. Let's say this should be your point. Right? So now, whenever it is 0, this is point. Right? Whenever this is infinite, it is never touching the axis. It is very, very close to 0. At infinite, at 0, this will be infinite. And at this 0, sorry, at this infinity, this will be the point, right? And at the same in the -1 line as at -1 point also, there will be a similar point. Right? So this will be your y is equals 1 by x. So now the homework is y is equals 1 by x. I'll just tell it right now. You can do it by this. So what will be for y is equals 1 by x squared? Just compare x by x squared. Then you can get. So you just compare it with x by x squared, you can get something. But if you compare with 1 by x, right? What y it will get? What y you will get? Just see by that. If we compare it to 1 by x. So at what point it will touch 1 by x? So if you do that, it will become x equals 1. So at x is equals 1, okay, this y is equals 1 by x square will intersect the y is equals 1 by x. Okay. Now just do the things. At 0 in this region, what it will become? Because at 0, x is equals 0, obviously y is equals infinity. There's no doubt. And at x is equals infinity, y is 0. This thing is already known because if be it y is equals 1 by x or y is equals 1 by x square or y is equals 1 by x cube. In every possible case, if the function is 1 by x, that means this thing is valid. This will be there. So what will become for this? Now in this region 0 to x, this will be x square will be less than x, and at x is greater than the 1, so x square will be greater than x. So just in this region, whenever it is from 0 to 1, it will be going to just behind that. And this is going to be that. Obviously, infinity will occur. So you can see it. Okay. So I will end here for today, but I'll come up with some mathematical equation that is found in chemistry and discuss it with you. So today I have discussed many such polynomial. Just read it and you can ask me any doubt there in the comment section. Okay. So thank you everyone for listening to the class and see you soon in the next class.